In this video, I will be going over how to find critical values. So to find a critical value, this is where the derivative of f, or f prime of x, equals 0, or when f prime of x is undefined. And there are two kinds of critical values that we can see. One is the local maximum and one is the local minimum. Another name for local max is relative max, and another name for local min is relative min. If we are looking for a local max, the first thing we want to do is take the derivative of f and set that equal to 0. And then we want to see whether the function is increasing before that x value and decreasing after, in which case that will be a local max. And if the function is first decreasing and then increasing around that x value, then that will be a local minimum. Let's look at an example. So we have f of x equals x plus 1 times x minus 1 squared. So the first part of this question is asking us to find all of the critical values. So the first thing we want to do is we want to find f prime of x and set that equal to 0. So in order to find f prime of x, well, this function is being multiplied. So this is our first function, and this is our second. And in this case, we will want to use the product rule to find the derivative. So we'll take the derivative of the first function. The derivative of x plus 1 is just 1. We leave the second function alone. Then we do plus, leave the first function alone, x plus 1, and then we'll take the derivative of the second function. So for the second function, we're going to bring the 2 to the front, and then we're going to subtract 1 from the power, so 2 minus 1 just gives me 1, and then I don't need that 1 there. And then we'll take the derivative of the inside function, but the derivative of x minus 1 is just 1. Now I can simplify this to be x minus 1 squared plus 2 times x plus 1 times x minus 1. Now since I want this to ultimately equal 0, it's best for me to try to factor out a GCF so that I can more easily solve this. So I noticed that they have x minus 1 in common, so I want to factor out x minus 1. Now I can leave a blank, 2 blanks there. So x minus 1 times something gives me x minus 1 squared. So I'll put an x minus 1 right here. And then x minus 1 times something gives me 2 times x plus 1 times x minus 1. So that will be 2x plus 1. Now I can just go ahead and use the distributive property inside, so I get 2x plus 2, and then I can combine like terms. So 2x plus x gives me 3x, and negative 1 plus 2 gives me positive 1. And now that it's my f prime of x is in this form, now I can more easily set this equal to 0 and solve. So now I can say that x minus 1 times 3x plus 1 equals 0. So I can just set each of them equal to 0. If I add 1 to each side, x is 1, and then if I subtract 1, I get 3x is negative 1, and then if I divide by 3, I get that x is negative 1/3. So these will be my two critical values. Those are the two x values that give me f prime of x equal to 0. Now the next part of this question, we want to find the x coordinates of the local max and the local min. So now we just want to test out these x values and see whether the function is increasing or decreasing around those points. So what I'm going to do is I'm going to draw a number line, and since I have negative 1/3 and 1, I'm going to put the smaller number to the left. Okay, and now I want to see kind of what's happening around these x values. So I want to test out an x value that's slightly smaller than negative 1/3. I just want to choose a number that's easy to plug in, so I'm going to test out x equals negative 1 because negative 1 is less than negative 1/3, and I'm going to test it into the derivative function. So my derivative function was right here in pink. So I want to test out negative 1 into here just to see whether the derivative is negative or positive. So f prime of -1 would give me -1 minus 1 times 3 times -1 plus 1. Now we don't need to solve for the exact value, let's say. All we need to see is whether this is a positive or a negative number. So -1 minus 1 is a negative number, and then -3 plus 1 is also a negative number. So a negative times a negative will give me a positive. So because this is a positive, since the derivative is positive, then that means that f is increasing. So then I'll draw an arrow to show that the function is increasing before -1/3. Now I want to test an x value in between -1/3 and 0 and 1. So an easy one to test would be x equals 0. Once again, I'll test that into the derivative function. So now I'll get 0 minus 1 times 3 times 0 plus 1. 0 minus 1 is a negative number, and then this becomes a positive. So a negative times a positive will give me a negative. So because the derivative is negative, then f will be decreasing. So I'll put a minus sign here to show that f prime is negative, and then I'll draw an arrow to show that the function is decreasing. So now that we can see that the function was increasing and then decreasing around -1/3, that means that at -1/3, we will have a local max. Now the last thing I just need to check is what's happening after x is 1. So I can maybe test out x equals 2. So I'll plug that once again into the derivative function. And so f of 2 becomes 2 minus 1 times 3 times 2 plus 1. So that would give me a positive times a positive, which is equal to a positive number. So because the derivative is positive, then f is increasing. So I'm going to put a plus here and show that the function is increasing. So now that we can see that the function was decreasing before x equals 1 and it was increasing after, then that will mean that at 1 we will have a local minimum. So now our final answer is that f of x has a local max at x equals -1/3 and a local minimum at x equals 1. And this is all we had to do here because this question only asked us to find the x coordinates, so we didn't also need to know the y coordinates of where those two values occurred.